So that is how you obtain it. Okay. We are going to continue. Okay. Uh, we can try out another number. Hoping we are on the same page. Now the other number we are going to try out. Because always it is better you learn, but still the second approach to that number, yes, I can do the second approach to that number. The number we have just finished. This number can as well be done using the another approach. And how do we approach it? So in case I have ln x minus 3. So I know very well that whenever this is the same as having ln of x minus 3, everything to power half. But when we come to, I want you to remember always, when it comes to logarithms, that when I have ln of a to power m, it is the same thing as having m ln of a. So when I apply that rule, it means that I can have a half ln of x minus 3. Now, when I reach here, I can now apply my differentiation. So I can say that d of the x of my a half of ln of x minus 3, if I'm to apply my what? My differentiation. So here, it means that what I can do, I can factor out their half, then I remain with d dx of the ln of x minus 3. And now when I am differentiating, I can use this principle that it will be f prime x out of f of x. But what is our f of x? Our f of x is x minus 3. So meaning that f prime of x is equal to 1. So here I can just come and say this is 1 out of 2 times here my f of I'm getting 1 divided by the original function, which is x minus 3. So I have 1 out of 2 into x minus 3. So you can also approach it from that direction. The beauty, you'll still get the same answer. Okay. Okay. So we are going to try out another number, because we need to learn how to yes. So another number we are going to try out, I think that is going to be our number 4. Now, knowing the product rule, knowing the chain rule is as well very important, because they can help you a lot. Now here we have 3x power 5 ln of 6x. And now that is what we are going to do. Now, when you look at that number, you can notice that this number, we are going to apply our rule. But which rule can we use? We can either use our rule that involves the product of two functions, meaning that we are going to apply the product rule, and meaning that you need to know how the product rule works. How does it work? You know that when I have d dx of uv, here the rule will tell us this is u dv dx plus v du dx. So for this particular one, this one can be our u, then this one can be our v. So when I will say u is equal to 3x power 5. So meaning that my du dx is going to be, I drop the power, it becomes 3 times 5, which is 15. I reduce the power by 1, I get x power 4. So in case you don't know, you do it as a side work. You say this is 3 times 5, then x 5 minus 1, which is 15x power 4. Then I have my v, which is ln of 6x. But we have already said that always whenever you meet a ln, you always differentiate your function, then divide by your function. So for this case, our function is going to be 6x. And therefore, f prime of x is equal to 6. So here to get our dv dx, I'll only say this is 6 out of the 6x. And when I reduce, I'll have dv dx is equaling to 1 out of x. Then I'm going to substitute. So I'll say my dx of my function 3x5 ln of 6x will equal to my u. So my u was 3x power 5, then times, I multiply it times dv dx, which is 1 out of x, plus v. Our v was ln x6x, then times du dx. So when I look at my du dx was 15x power 4. So you can notice that this x here can easily reduce by x1, by x here, they reduces and you remain with only 4. So here I'll have 3x power 4 plus, you are going to allow me to begin with 15x power 4, then ln 60x. Reason being that you may, some of you at times make mistake and you easily multiply x times x power 4. So of which you cannot multiply those two things. So here you cannot, when you look at it, well, this is x power 4, x power 4. There is a 3, there is a 3 in the 15. So meaning I can factorize out and I say this is 3x power 4 into 1 plus, remember we have factorized out 3. So meaning that 15 goes into 3, how many times? 5. So here I can have 5 ln 60x. And therefore, if I want, I can end at that particular point. So that is how we differentiate, but also when we are applying other laws. Okay, we can do another one. We can do another one. One more. Another one. Okay. Okay, another one we can do. We can try out another one. Say we have ln of 3x out of x power 4. Now here, we shall use our knowledge of the quotient rule. So you remember that from our quotient rule, ddx of our u out of v, we said is the same as having always our v du dx minus our u into the v dx. So meaning here I can say I'll have my v du dx minus u dv dx, divide everything by our v squared. So when you look here, I can select my function of y equals to ln of 3x out of x power 4. So you're going to say, let your numerator is the u, ln 3x. Then your denominator v equals to x power 4. When you look at our function there, you'll notice that our function, you will need du dx, but also you need the dv dx. So meaning you need to find them. So meaning that here, our du dx, we have said always differentiate the function, which is 3x. So when I differentiate, I get 3 divided by original function, which is 3x. So meaning that our du dx is the same as 1 out of x. Then our dv dx, I'll say dv dx will equal to 4x power 3. Now, after obtaining that, then it means that I can go on and I substitute in my formula. So when I go back, I'm going to substitute my v. We have it as x power 4, then times our du dx, which is now 1 out of x, minus u, which is ln 3x, then times the other one, which is 4x power 3, everything divided by v, which is now x power 4, everything squared. So you can easily tell, or you can note that this x and here, they are going to reduce. So here, we shall remain with x power 3 minus, here always better, you write this first, then you say ln 3x out of here 4 times 2, it will give us x power 8. Now, what are you noticing? We can reduce further. When you look at the numerator, you can easily tell that x cubed and x cubed are common factors. Mean that if they are common factors, I can factor it out. I say x cubed into 1 minus 4 ln of 3x. That is very important. Then down, I have x power 8. And now we can reduce. These are 3, these are 8. So when they reduce, it means we shall have 1 minus 4 ln of 3x out of, remember they were 8 and the other ones were 3. So when you reduce, you remain with 5. So down here, we shall remain with x power 5. And now this one is going to be our derivative ddx of ln of 3x out of x power 4. So that is how you approach such numbers that will involve you to use the quotient rule. Let me hope that one is very, very fine. So you can go on to try out other numbers. Even if you find, sometimes you may find numbers of this nature. Let me say this is our number 6. Even if you find that you have things that look a bit complicated, for you, please, you must apply the rule. Take an example. You can find something like this, ln of 5x plus ln of x. Still do the same. You first let, you know what you know very well, that you have to differentiate this. So you can decide to say that let my u equals to 5x plus ln of x. Then go on and differentiate and say, here I'll have my du dx is equal to, when I differentiate 5x, I'll get 5. Plus, when I differentiate ln x, I'll have 1 out of x. Then remember now that your y is going to equal to, your y is going to equal to ln of u. So meaning that your du will equal to 1 out of u. So when you go back, it means you say that my dy dx will equal to dy du times my du dx. So here we have dy du, which is 1 out of u, then times du dx, which you obtained as 5 plus 1 out of x. So when you get 1 out of u, you say 1 out of 5x plus ln x. Then everything you're multiplying times 5 plus 1 out of x. Now what you can do, whenever you are faced with such numbers, you can go on and reduce. You look at the number and ask yourself, can this number be reduced any further? And in case you look at it and say, it can be reduced, then you go on and reduce. So how are we going to reduce? So it means that I can deal with this thing I have this side. When you look at it, fellow, you have 5 plus 1 out of x. Here, our LCM is x. So meaning here we have 5x plus 1. So meaning that in the numerator, we shall remain with 1 out of 5x plus ln of x. Then the numerator you'll have 5x plus 1 and everything will be out of x. So which you can reduce further and say this is 5x plus 1 out of x into 5x plus ln of x. So that is your answer. Okay, let me hope you have picked that. So allow me to give you some numbers for you to try out. So may you try out these numbers. These are the numbers that I would love you to try out. This is like your exercise, and we shall say differentiate with respect to x. So number 1, ln of 7x. Number 2, 6 plus ln of x cubed plus 3. Number 3, ln of 3x plus 5 squared. Number 4, ln of 2 minus x power 3. Number 5, ln of 2 out of 1 minus 3x. And number 6, ln of 3x minus 2 out of x squared. Number 7, ln of 2x plus 3 out of 4x minus 1. And then number 8, you can try out a ln of 2x plus 3 out of x minus 1. So you can try out those few numbers to check whether you have learned how to differentiate logarithmic functions. But do not forget, our rule always will remain the same. So let me wish you a good evening. Thank you for attending and have a lovely day.